This is your Unit 1 lesson on safety and green chemistry. We will be giving this lesson live in class, and during class time, we will be watching Lab Techniques and Safety Crash Course Chemistry number 21. If you happen to miss the class, you will need to watch this video on your own. You can do this by using the slides that are posted, by searching Google and just putting in Crash Course Chemistry number 21, or by following the YouTube link I am going to post within the lesson. So you'll need to do that. In order to take the notes that are required, you'll need to watch this. Now, that being said, it's very important that you do this. Lab techniques and safety and safe lab techniques are absolutely essential in our chemistry lab. And you're going to have a test about this later on in the course. So be sure you have watched Lab Techniques and Safety before moving on in this presentation. It's going to look a little bit something like this.
Some of the best moments of my life have
Hank
happened
Green.
in labs. Also, some of the worst.
All right, with that being said, I will make the assumption you have gone and watched the video and taken the notes. As an extension of safety, I want to talk to you a little bit about something called green chemistry. Green chemistry is the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. Green chemistry applies across the life cycle of a chemical product, including its design, manufacture, use, and ultimate disposal. As we do labs in class, and as you decide perhaps on your science projects, I want you to keep green chemistry in mind. Instead of thinking about how certain chemicals can harm, you need to be thinking about how you can minimize harm and maximize benefit. So you do need to reframe thinking about your science projects, and I've had to reframe thinking a little bit about our labs. We want to be sure that we are not generating hazardous substances. That's not useful for our environment. Now, what are the benefits of green chemistry if you switch your mindset? Well, it prevents pollution at the molecular level. It's a philosophy that applies to all areas of chemistry, not a single discipline of chemistry. It applies innovative scientific solutions to real-world environmental problems. It results in source reduction because it prevents the generation of pollution. It reduces the negative impacts of chemical products and processes on human health and the environment. It lessens and sometimes even eliminates hazards from existing products and processes. And it designs chemical products and processes to reduce their intrinsic hazards. Chemistry or chemicals do not have to be a bad thing, but you have to think about how they are used, how they are disposed of, and how you can mitigate any problems and negative impacts. Now, how does green chemistry differ from just cleaning up? Green chemistry reduces pollution at its source by minimizing or eliminating the hazards of chemical feedstocks, reagents, solvents, and products. This is unlike cleaning up pollution. Sometimes you'll hear about remediation, which involves treating waste streams, the end of the pipe treatment, or cleanup of environmental spills and other releases. Remediation may include separating out hazardous chemicals from other materials and then treating them so they are no longer hazardous or concentrating them for safe disposal. So it's a little bit different than cleaning up. We're thinking about not generating the pollution in the first place, not having to do remediation because we're not generating that pollution. So there are 12 principles of green chemistry, and you may want to just write down the things in bold as a reminder, especially as you're thinking about your own science projects. You want to practice these principles of green chemistry as you're designing your procedure. You're going to prevent waste. That means design chemical syntheses to prevent waste, leave no waste to treat or clean up. You're going to maximize atom economy. What that means is you're going to design a syntheses, you're going to make chemicals so that the final product contains the maximum proportion of the starting materials. You're going to waste few or no atoms. Number 3, you're going to design less hazardous chemical syntheses. So in other words, things that are not toxic. You're going to decide safer chemicals and products. Design chemical products that are fully effective and have little or no toxicity. You're going to use safer solvents and reaction conditions. Solvents are the things you dissolve things in. You're going to avoid using solvents, separation agents, or other kinds of chemicals. And if you must use chemicals, you're going to use safer ones. You're going to increase energy efficiency. You're going to run chemical reactions at room temperature and pressure whenever possible. You're going to use renewable feedstocks. What's a feedstock? That's your starting material. Use starting materials that are renewable rather than depletable. The source of renewable feedstocks is often agricultural products or wastes of other processes. The source of depletable feedstocks is often fossil fuels. We can't regenerate them. They've been under the ground for millions of years and we're pulling them up. We're using them up. We want to look for things that are renewable. You're going to avoid chemical derivatives. You're going to avoid using blocking or protecting groups or any temporary modification if possible. Derivatives use additional reagents and generate waste. I know some of these words are kind of scientific sounding and you may not be as familiar with them, but it's important to start to think chemically and to think about what these words mean. Number 9, you're going to use catalysts because you minimize waste when you use catalysts. You're going to design chemicals and products to degrade after use. You're going to design chemicals that break down to innocuous, that means harmless substances after use so they do not accumulate in the environment. You're going to analyze in real time to prevent pollution. So you're going to think about what you're doing and how you can minimize real-time pollution. And you're going to minimize the potential for accidents. You're going to design chemicals and their physical forms, solid liquids or gases, to minimize the potential for chemical accidents, including explosions, fires, and releases to the environment. That's why we have this thing of green chemistry in our safety unit. That is the discussion we have right now on both safety and green chemistry. Be sure you have watched Crash Course Chemistry number 21 on lab safety and have taken your notes.